Today we are combining 10-1 and 10-2. 10-1 is an introduction to volume. We've done some volume problems throughout the school year, and you see them sometimes even in your warm-up. Volume is the amount of units you could fit inside of a three-dimensional figure. So area is the space inside, say, a square, but volume is how much is inside a box or a cube. Okay, so we're going to apply the formula that volume is equal to length and width, which is area, and we're going to multiply it times the height. And also that volume could be equal to whatever the area of the base is here. If I took the area of my base and I multiplied it by the height, that would give me a measure of volume. So let's explore. Volume is the number of cubic units needed to pack a solid figure without any gapping or overlapping. A cubic unit is the volume. So like this cube here, normally we're going to use a unit such as inches or feet, yards, some measure of length. But this time we're just using units to be kind of generic. And it says it's 1 unit high, 1 unit wide, and 1 unit deep. Okay, so the volume is three-dimensional. We're going length, width, height. And I know I use depth in there, and it's all kind of the same terminology. This is the official mathematical formula. So it's 1 unit this way, 1 unit that way, 1 unit this way. So it is 1 unit, and we say the unit is cubed because it's unit times unit, that would be squared, times unit one more time to the third power, we read that as cubed. Okay? What would the volume of this rectangular prism be in this picture? Well, one strategy we're going to say is you could look across the bottom. Let's find out how many cubes are along the bottom. And if I look here, I go across 5. 1, 2, 3, 4, 5. And then I go back 3. 1, 2, 3. So 5 rows of 3 is equal to 15 cubes on the bottom. Some people would look right here at the top and say, well, this is easier for me. I'd say I could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And count them that way. Either way you do it, there's 15 unit cubes in one layer. How many layers are there? Well, there are 2 layers. So you multiply the 15 from the bottom layer by 2. So the volume of the prism is 2 times 15, or 30 cubic units. Counting works well if it's drawn that way, but sometimes you're going to calculate volume and it's not drawn with cubes inside. So let's check our formula. The volume formula, volume equals the length times the width, which is area of the base, right, times the height of it. And let's check it. Well, this is 5 units across. It is 3 units wide, and it is 2 units high. So 5 times 3 times 2 with my formula equals 30. Sometimes kids will get a little bent on, well, which one's the length and which one's the height? It doesn't matter, really. You need to know that all 3 components make up volume. But truthfully, because of the associative property, I could multiply these in any way. I could say 2 times 3 is 6 times 5. It still equals 30. Or I could say 2 times 5 is 10 times 3, and that equals 30. So it does not matter truly which is the length, which is the width. Make sure you include all 3 in your calculation. So I'm going to go ahead and have you try this with the example that has the blocks drawn. What is the volume of this figure? Personally, I might count how many blocks I see on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see 12 blocks on top, and there's 2 layers. So my area is 12 times 2, or 24. It's not marked in feet or inches, so I'm going to say 24 units wide, high, and long. So that is to the third power. Okay, let's try a little trickier one. What would you do here? Because I can't count how many units high because it's not the same height all across. The best strategy here would be to split this into two prisms. Okay, you have to use a little imagination, but I would look at this prism here and I'd say, oh, I can just count these blocks. There's 1, 2, 3, 4, 5, 6 blocks on this side. So 6 here. I'm going to write that in purple so we can see it a little better. 6 blocks there. And then I am going to come over and use my formula maybe, or just count the blocks in this side. And if I look at this side, I'm going to count the blocks that are in the front layer. 1, 2, 3, 4, 5, 6, 7, 8. And I have 2 layers of that. So 8 times 2 is 16. Well, 6 plus 16, my volume of this shape is 22. Again, I don't know the units, so I'm going to use the generic term units cubed. Easy. Again, when you're counting, you do this one. So let's write the formula for this instead. Let's look. 1, 2, 3, 4. 4 units long. 1, 2 by 2 units wide. And 1, 2, 3 by 3 units high. My volume for this shape, 4 times 2 times 3. And that one also is 24 units cubed. But you can use the formula as well. All right, now this is moving on to 10-2. We know the formula here. Kevin needs a new aquarium for his fish. The aquatic store has a fish tank in the shape of a rectangular prism that measures 5 feet by 2 feet by 4 feet. Kevin needs a fish tank that has a volume of at least 35 cubic feet. Will this tank be big enough? Yes. How do you know? Well, this tank, 5 times 2 is 10 times 4, has a volume of 40 cubic feet. So he needs at least 35 since 40 is more. Kevin can buy that tank. There you go. Let's practice. The essential understanding that you need to have for the practice is that formulas can be used to find the volume of rectangular prisms and cubes. Formula for area is length times width. Formula for volume is 3-dimensional, so we add one more. It's length times width times height. Here we go. How can you use the formula? Remember that volume is the number of units needed to pack a solid figure without gapping and overlapping. You can find the volume of a rectangular prism by counting. That's great. But counting it's easy to miss a cube or miss a layer. If we take the dimensions and use the formula, you're not going to make the mistakes. The dimensions of this prism are 6, 4, and 3 units respectively. What is the volume? Right? Length, width, height. Well, the volume is the length times width, so 6 times 4, which is also, by the way, the area of the base. Sometimes you're going to hear that we say the volume is the area of the base. You find this length and width, and then you multiply it by the height. And that's how we got 72. If I told you this dictionary was 3 inches thick, what would the volume be? Well, some people may have said 63 because you just took the area of, say, the cover or one side of it, but we forgot to say that it is 3 inches thick. It is 9 times 7, which is 63, times 3. And that's where we got 189. My unit is inches, and it's cubic units because it's length, width, height. Try this one. Excellent. So on this one, you could combine them and multiply them anyway. 8 times 5 is 40 to me. That was easy to get that, and I just took 40 times 4. And that, because of the basic fact, 4 times 4 is 16, and that's an easier way for me to do it. Some of you may have said 5 times 4 and got 20, and then multiplied that by 8. That works too. So it does not matter the order in which you multiply them. Okay, try this one for me now. What would be the height of a rectangular prism that had a volume of 280 cubic meters, a length of 8, and a width of 7? So this one is now adding that it's missing a different component, the height. We know volume is length times width times height, and that equals the volume. So let's substitute our numbers. 8 times the width of 7 times the height would equal 280. Well, 8 times 7 is 56. 56 times h equals 280. What would I have to multiply 56 by to get 280? Yes, that is why the height would just equal 5, and it would be meters. This is not cube. This is one dimension. It's just the height. So it's just meters in the singular form. I knew I was going to have writing over this. Let's see if this... an Outer Bay exhibit at Monterey Bay has a viewing window here. The important part is not covered. That is 56 5/10 feet long, 17 feet tall, and 13 inches thick. Estimate its volume in cubic feet. What do you see first of all? 56.5 feet, 17 feet, 13 inches. Right. We need to take this and we're estimating. So 13 inches, if there's 12 inches in 1 foot, what's a good estimate for the number of inches? I agree. 13 inches, the number of feet, the estimate would be 1 foot. Okay. So it's 1 foot. We want to change this to make a number easy to work with. You could say, it asks for an estimate. You could say, I'm going to call that 60. 1 foot by 60 feet. And let's make these numbers easy to work with. Let's call that 20. So 1 times 60 is 60 times 20. Well, 6 times 2 is 12. 60 times 20 is 1,200. A good estimate is 1,200 feet cubed. Now, what if Nat uses this expression? This is on your practice buddy, so I wanted to offer one practice on it. Nat used the expression 3 times S to find the cost of what 3 shirts are. What is the value of the expression if S equals $16? So this is what we did last week. We substituted. 3 times S equals the shirts. Well, the shirts are equal to 3. Let's substitute the value of 16 in for S. 3 times 16. And then the value of the shirts would be $48. Okay. Well, I think you're good to go. That's it, kiddos. Go ahead with the practice buddy and let me know if you have any questions. Thank you.